The North Sea environment violently punishes floating vessels. Yet, to drill complex wells, operators must maintain a perfectly stationary platform regardless of the swells. That is the core operational paradox of this region. The solution is the Category J, or CJ70, rig class. Designed by Gusto MSC and built by Samsung and Jurong shipyards, this class consists of three primary sister units: Askapot, Askeladdin, and the Noble Lloyd Noble. On the right, the Cat J silhouette dwarfs a standard jackup. Its certified operating envelope reaches water depths of 150 meters and enables a drilling depth capacity of 10,000 meters, nearly double what conventional units can achieve. These massive physical dimensions are dictated by the 10,000-meter target. Pushing that deep in a harsh environment creates enormous vertical and lateral loads. The rig is sized specifically to manage those calculated structural requirements. Think of the class like a Boeing 737. Two airlines can fly the same 737 airframe, but the engines, cockpits, and internal equipment differ. Sister units share the CJ70 baseline design, but because their configurations evolve over time, engineers must qualify the specific rig, not just the class. The 700-foot legs utilize an X-braced lattice structure. Instead of a solid steel column, which would be prohibitively heavy, the triangulated bracing converts bending loads into simple tension and compression, optimizing the strength-to-weight ratio for a 214-meter span. At the base of each leg is a skirted spud can. This works like a snowshoe, distributing the rig's weight over a wider area of the seabed. The steel skirt bites into the mud to provide mechanical resistance against lateral sliding and vertical punch-through in soft clay. If a site survey shows a hard sand crust sitting over a layer of soft clay, what is the greatest risk during jackup? Punch-through. The leg appears to find solid resistance on the crust, but can suddenly break through into the clay below. This risk is why preloading is always done incrementally, with continuous monitoring. Stabilizing the foundation on the seabed is the non-negotiable prerequisite. If the spud cans fail to hold, the structural integrity of the entire rig above the waterline is lost. Once positioned, the hull climbs its legs using an electric variable speed drive rock and pinion system. No hydraulic rams or cables are used. Individual electric motors turn pinion gears against a central toothed steel rack to lift the entire platform. Because independent pinions lift the rig simultaneously, micro-variations in speed create rack phase difference, or RPD. If one pinion climbs faster than its neighbors, it creates uneven, twisting loads that can damage the lattice structure. To protect the jacking system during drilling, a counter-rack fixation system locks the hull to the legs. At operating elevation, these racks mesh into the legs to transfer the structural load entirely away from the jacking motors. Operating discipline is absolute during this process. Because excessive RPD can destroy a leg cord, an RPD alarm is a hard stop for immediate investigation, never a suggestion to be ignored. Every system relies on an electrical backbone of diesel generators and SCR VFD cabinets. In 2024, Askapot achieved a milestone by electrifying via shore power from the Martin Ling A platform, eliminating approximately 20,000 tons of annual CO2 emissions. The deck layout wraps the 140-person accommodation block around the forward leg. This design ties the quarters into the rig's strongest vertical member and maximizes the physical distance between the crew and the drill floor. On the drill floor, variable frequency drives meter out precise power, powering the massive drawworks, the overhead top drive, and high-pressure mud pumps. They are built specifically to sustain operations at 10,000-meter drilling depths. To reach targets more efficiently, the Gusto MSC XY cantilever moves both longitudinally and transversely. By skidding across both axes, it doubles the drilling envelope compared to conventional designs, allowing the rig to hit more targets without repositioning the hull. Unlike floating rigs with subsea units, a jackup uses a surface blowout preventer sitting at deck level. Because the BOP is above the waterline, the high-pressure riser requires dedicated lateral support systems to manage loads and motions along its run to the seabed. In the driller's cabin, the operator manages these systems through advanced human-machine interfaces like NOV Cyberbase. Automation here handles the complex synchronization of mud pumps, jacking units, and skidding. However, a have-till audit revealed that while automation reduces manual labor, it introduces cognitive risks. The primary challenge is alarm fatigue, where operators become desensitized to a high volume of digital alerts. This creates the automation paradox. Over-reliance on digital readouts can cause an operator to lose their intuitive feel for the well. When focus is restricted to a screen, the engineer can become separated from the physical reality of the hardware. The ultimate safety system is an engineer who respects physical limits. Use these 4 golden rules as your foundational checklist. 1. Respect the 150-meter water and 10,000-meter drilling depth limits. 2. Ensure the air gap clears the 100-year wave plus margin. 3. An RKD alarm is a hard stop. And 4. A surface BOP requires dedicated lateral riser support.